In this question it is given that there is a hole in the bottom of a tank having water. If total pressure at the bottom is 3 atmosphere, then the velocity of water flowing from the hole is. So over here we are considering there is a container and there is a small opening over here through which liquid is coming out with some velocity, let's say that is equal to V. So the pressure at the bottom part means, to apply Bernoulli's theorem we are just considering 2 points. One is inside the container and second point outside. So we can write Bernoulli's theorem, that is P1 plus half into rho into V1 square plus rho into G into H1 is equal to, we can take it as P2 plus half into rho into V2 square plus rho into G into H2. Now for the application of Bernoulli's theorem, we are taking this bottom of container as nothing but a reference line. So pressure over here, which is given in question as nothing but 3 atmospheric pressure, plus velocity of water inside is 0, so we can take it as 0 kinetic energy plus gravitational potential energy is also equal to 0. Pressure outside is nothing but 1 atmospheric pressure plus our aim is to find out what about the value of velocity of liquid outside, which we can take it as half into density of water, which is 1000 into V2 square plus rho into G into H2, which is also equal to 0. So you can write 3 atmosphere minus 1 atmosphere, that is 2 atmospheric pressure is equal to half into 1000 into V2 square. So you can write 1 atmospheric pressure is 10 raised to 5 Pascal. So this is 2 into 10 raised to 5 into 2 divided by 1000 is equal to nothing but V2 square. So we can write this as 400 or root of 400 is the value of V2.